Imagine building a bridge without a crane. Now imagine doing it 92 meters above the ground with a machine that moves like a beast on rails. While most countries rely on traditional methods, China is engineering monsters. From machines that lift entire highway segments, to transporters that can move a 10,000-ton structure sideways, to tunnel borers carving through mountains like they're made of butter. These are not construction tools, they're weapons in a race to build the future faster. They call it the SLJ 900, or more dramatically, the Segmental Bridge Erector. It stretches 92 meters long, weighs over 580 tons, and builds bridges without using a crane. Developed in China, this monster machine was engineered to simplify one of the most complex tasks in modern infrastructure: segmental bridge construction. It moves on its own, gliding from pier to pier, lifting, aligning, and installing massive concrete segments with surgical precision. But how does it work? Instead of relying on external support, SLJ 900 carries the bridge components on its own back. It moves forward, section by section, positioning each piece using integrated lifting arms and high-precision hydraulic systems. No scaffolding, no temporary supports, and most importantly, no delays. This allows for faster construction across rivers, valleys, and mountainous terrain, where traditional methods would be too slow, too dangerous, or simply impossible. And here's the genius part. The SLJ 900 can rotate, shift, and realign itself to follow curved or sloped paths. It's not just massive, it's adaptable. With a price tag of around 700 million yuan, roughly 100 million USD, this machine is not cheap, but for mega projects that demand speed, safety, and precision, it's an investment that pays for itself, one segment at a time. Bridges don't build themselves, but this machine gets pretty damn close. Meet the beam launcher, a massive steel structure that glides along newly built sections of a bridge, lifting and placing concrete beams that weigh hundreds of tons, all without a crane. In projects where terrain is tough and space is limited, cranes are too slow, too risky, or just impossible. That's where the beam launcher takes over. It rolls forward on rails, grabs the next beam, and positions it with extreme accuracy. Think of it as a robotic skeleton that builds its own spine, one segment at a time. What makes it so powerful isn't just size, it's precision. The system uses high-tech sensors and control systems, reducing margin of error to just centimeters. That means faster installs, fewer workers at height, and far less risk on site. Even on curved bridges or steep gradients, this machine adapts. It can follow complex alignments that would cripple traditional setups. In China's biggest bridge projects, this launcher isn't optional, it's essential. Forget cranes, forget flatbeds. This machine moves buildings. The self-propelled modular transporter, or SPMT, is a flat platform on wheels, but it's no ordinary trailer. It can carry thousands of tons, move in any direction, and rotate 360 degrees on the spot. Each wheel has its own motor. Each module can be connected, like Lego, and the whole system is remote controlled with surgical precision. In tight construction zones, or mega projects where components are just too massive, SPMTs take over. They transport bridge segments, turbines, even entire buildings, all while balancing perfectly on uneven terrain. What makes it brilliant is its flexibility. You can add or remove modules, scale it up or down, and control every wheel independently. In China, SPMTs are used in highway, port, and high-speed rail projects where conventional transport would collapse under the weight. And here's the kicker: it moves heavy loads without causing structural stress, so even the most delicate components arrive intact. SPMTs don't just move things, they move the future. Not all bridges are built from below. some hang from the sky. Welcome to the world of cable-stayed bridges, where massive pylons rise like steel needles and cables hold up entire roadways with perfect balance. But here's the challenge: installing those cables hundreds of meters above ground with millimeter accuracy and zero margin for error. That's where China's automated cable installers come in. These are not cranes. They're robotic launchers, engineered to climb pylons, position anchors, and tension cables with absolute control. Each cable must be placed at the right angle, pulled with the right force, and connected to a structure that's still under construction. The system uses GPS-guided automation, hydraulic winches, and intelligent load sensors to install each cable safely, efficiently, and without manual workers at dangerous heights. It's not just engineering, it's aerial choreography. And for super long spans, like the 100-meter Ping-Tang Bridge, this tech isn't optional. It's the only way to build. You're looking at a machine so big, it digs through mountains like a knife through butter. This is the Tunnel Boring Machine, or TBM, a rotating steel monster with cutting heads the size of a house. It doesn't just dig tunnels, it builds them as it goes. Each rotation slices through rock and soil, while robotic arms install concrete tunnel segments behind it, forming a reinforced shell in real time. No explosions, no collapses, no waiting for ground to settle, just smooth, continuous excavation, even through high-pressure zones or unpredictable geology. In China, TBMs are essential to building high-speed rail, subways, and underwater expressways. One machine used in Sichuan province measured over 15 meters wide, designed to bore through complex rock formations without pause. But this isn't just about speed, it's about safety. TBMs reduce risk to workers and minimize disruption to the surface above. So next time you ride a train under a mountain, remember this: it wasn't just built, it was carved by a steel beast that never stops. These machines aren't just tools, they're the future of construction, from tunneling under mountains to hanging roadways in mid-air. So here's the question: if this is what China is building today, what will your country need to catch up? Liked what you saw? We've got more machines coming, bigger, smarter, and even stranger.